Hello, my name is Nicoleta Falla, and our presentation today is on identifying weather information requirements for general aviation, pilots, and unmanned aerial systems operators. Urban air mobility has made huge strides in research in recent years, and it's creating new challenges and new opportunities for our community as well as the industry. We expect to have lots of variety in the vehicles that will be flying in the skies, and we have to be ready for those operations. At the same time, we have to be mindful that we are not starting with a blank slate. We already have vehicles operating in the same environment. WINMAP is tackling the weather part of the issue. WINMAP stands for Weather Intelligent Navigation Data and Models for Aviation Planning, and it's a 4-year-long NASA University Leadership Initiative led by Oklahoma State University. It aims to use UAS infrastructure to improve weather observation and forecasting models for low-altitude operations, such as other UAS, the emerging area of UAM, and the vehicles we are more used to seeing in our skies, such as those in general aviation operations. This whole infrastructure we're developing through WINMAP will result in our ability to provide what we have termed drone reps. Essentially, drone reps are automated weather reports that come from UAS acting as weather stations. The figure on these slides shows pilot reports, or PIREPs, that were in the system at the time of this recording. Pilot reports live on a system that can communicate information. So the figure that was displayed earlier was the Aviation Weather Center's website, but other products can communicate the same information. Pilots who are out there flying and reporting what they observe in real time can report icing, cloud-based turbulence, or even smooth air. All that information is useful to other pilots who are right now reviewing the weather and trying to make a decision on whether to go flying. All pilots have to do is use some sort of weather briefing tool, such as the Aviation Weather Center website, their electronic flight bag, or even call flight services to obtain any PIREPs in the area of their planned flight. If we go back to the initial figure, we can see that PIREPs are not that dense. Operationally, we end up with a lot of weather information close to airports, at altitudes where airliners and cargo airplanes fly, and the occasional GA PIREP at lower altitudes. The sparseness of the data will be a problem for urban air mobility, where we'll be flying in environments where things change very quickly, creating a need for accurate weather information that's made available quickly too. Within WINMAP, we aim to use UAS as a mobile weather station. For example, the orange UAS depicted can go fly for the sole purpose of collecting and disseminating weather data in an area that doesn't have sufficient weather stations. Other UAS, which also happen to be flying and also happen to have some sensors on board, can provide their own information too. UAS operators on the ground who are planning an operation can use that information to make decisions. Operators can also use real-time drone reps to make adjustments to their flight plan while their UAS is flying. And lastly, pilots of crewed aircraft can also use drone reps to obtain weather information that would not be available otherwise, both at low altitudes, but also in areas not currently served sufficiently. And that brings us back to WINMAP. The paper we're presenting here focuses on identifying gaps in our current system and the initial requirements that will help guide our research to enhance weather information. To do that, we developed a survey to collect data from GA pilots and UAS operators. Our survey asked UAS operators and GA pilots questions on how much different weather elements impact their decision to fly on a given day, how satisfied they are with the weather products they use to obtain observations and forecasts on those weather elements, and how frequently that forecast has resulted in a false alarm. All the questions are answered on 5-point Likert scales, and then we also asked respondents to input their personal limits for those weather elements, and we asked them about weather products, how familiar they are with them, how often they use them in flight planning and during flight. And at the end, we asked for demographic information. Our aviation paper focused on the first block of the survey and studies differences in how weather elements influence GA pilot and UAS operator decisions, and how satisfied those two populations are with their ability to gather any information they need. So we disseminate the survey using listservs, newsletters, social media, flight programs, flying clubs, drawing clubs, and we got a very high response rate. We got 535 responses from pilots, 49 from UAS operators, and 78 from respondents who are both GA pilots and UAS operators. Our analysis included visual observations from comparing histograms, descriptive statistics, and Wilcoxon rank sum tests to evaluate differences in the populations. We compared UAS operators and GA pilots to each other, but we also evaluated whether having the extra experience of the second field changes how you respond. I will only present some of the more interesting findings and will direct you to the paper for more details. The first question was how frequently do these weather elements influence your go or no-go decision? UAS operators said never for convective weather. GA pilots said always. The same thing happened with cloud coverage, icing, and wind shear. So why is that interesting? MIT Lincoln Labs had UAS operators rate the significance of these same weather elements, and convective weather in their case came at the top of UAS for UAS of all sizes. On the other hand, we've got turbulence and precipitation, which influence UAS operators more than GA pilots. Precipitation also made for an interesting histographic transition. GA pilots looked very normally distributed, but UAS operators were all really influenced by precipitation all the time. The Wilcoxon rank sum test confirmed that UAS operators and GA pilots responded differently for most of the weather elements presented. Having experience in both fields did not really change the responses too much. Moving on to our second question, measuring satisfaction with the products they use to get information on each weather element. Overall, everyone seems to be at least neutrally satisfied. The UAS operators are in general less satisfied than GA pilots, which makes sense. When we designed those weather products, UAS were not around, so those products did not include them in the design. The Wilcoxon rank sum test showed differences in opinions for convective weather, winds aloft, and pressure. Once again, UAS operators, they said that convective weather does not influence their decision making, but they're not quite happy with the products out there either. The third question aimed to measure the frequency of false alarms. The results are great news for the most part. We really don't have too many false alarms. However, UAS operators struggle more with surface winds and gusts, and GA pilots cancel more often because of cloud coverage. So we can focus on those elements, those three elements, if we are improving weather information. The analysis for this paper covered the first block of questions in the survey. We've got lots more data to work through, and there will be a second paper for the last two blocks in the survey. We plan to use the results from this work to start developing requirements for WindMap based on the needs of UAS and GA communities. The most impactful preliminary finding for now is that UAS operators have an operational need for improved weather products for convective weather and winds aloft, and that should be our priority. The improvements required may be in observations and forecasting in terms of reduced uncertainty or increased temporal and geolocational resolution, or in weather information display and communication. So in future work, we will consider conducting structured focus groups with UAS operators to solicit data, which will result in more detailed requirements. I will be happy to answer questions and share more about WindMap during the forum or at any other time over email.